Alright, what's up everyone? We are moving on to antiderivatives with what we call u sub. Alright, I can imagine the jokes already. So in our first example, I see that I could take the integral of this, but it'd be pretty difficult because we already learned that there's no rule for product rule, right? So I could do the distribution here. I could multiply this by itself 5 times and then distribute 2x. That would be a huge pain in the butt. So what we can do instead is do a u substitution. I can make a substitution for this more complicated polynomial, this term here, and see what happens. So what I'm going to do is let u equal x squared plus 1. Now there's several things I look for when I assign u to a value. All right, typically I want u to be of a higher power than the other function here. So I see that there's x squared plus 1, I have 2x here. I want u to be of a higher power because I'm going to take the derivative. Okay, so I'm kind of looking for one part of my function to be u, and I'm looking for the other part to be the derivative of u. Another thing I look for is I'm looking for u to be kind of inside the function. So I want something to be happening to you. I want it to be more like the more complicated option, right? So I have x squared plus 5 inside of the fifth power. So I'm going to let that be u. Okay, those are the things that I typically look for. Okay, now I can make my substitution. So I see pretty clearly that x squared plus 1 is my u value. And then here, 2x dx is the same thing as du. So when I substitute, I really just have u to the fifth, and then all this stuff is equivalent to du. Now this is a much easier integral than this is. All right, it looks simpler. I mean, this really isn't that hard because if you think about it this way, you do it the same way. But if you make the u sub, it looks a lot easier. All right, so I can take the integral as just 1/6 u to the 6 plus c. And now I'm just going to substitute this u value back in because my original function was not in terms of u. All right, and that's it. That is my integral. Let's do another one. All right, so we just practice figuring out what we're going to let u equal. That's the biggest thing at this point. If you can figure that out, then you're in a good place already. All right, so right off the bat, I see that 2x cubed plus 5 is inside of the fourth power, so that's already a good candidate, plus it's of a higher power. So 2x cubed plus 5 is definitely a good candidate for u. Take the derivative, and I have 6x squared. Okay, now let's take a look at what we had here. Okay, we have 2x cubed plus 5 to the fourth power, and then x squared dx. Okay, now this we already decided was going to be u. Now here, this is x squared dx. Sorry. Now here I have 6x squared dx. So that means that 1/6 du is equivalent to x squared dx. I just divided both sides by 6. And now I see that I have the exact same thing. So x squared dx is equivalent to 1/6 du. That means I can just make this substitution. So u to the fourth times 1/6 du. Remember, I can bring constants out, so I have 1/6 integral of u to the fourth with respect to u. Now we'll take this integral. So it's 1/5 u to the fifth plus c. So that's going to be 1/30th, and then I'm going to make that substitution again. So 2x cubed plus 5 to the fifth power plus c, and now I'm done. All right, not too bad, right? Or maybe you think it's the worst thing ever, I don't know. All right, again, I have x squared plus 3, it's of a higher power, and it's inside the square root. Definitely good to be u. So du is going to be 2x dx. Now again, if I rearrange this a little bit, I have x dx. I do not have 2x dx. So I have to divide both sides by 2. And so now I see this is u. This is equivalent to 1/2 du. Right? So I'm just going to take that 1/2 out to the front of my integral like I did in the last problem. I have u to the 1/2 power du. Right? So all the elements are there. I just rearranged it a little bit. I'm going to add 1. So I'll have 3 halves and divide by 3 halves, same thing as multiplying by 2/3. Right, and then I just make that substitution. So these fractions will cancel to be 1/3. I get x squared plus 3 to the 3 halves plus c. All right, not too bad. All right, similar deal here. So again, I see 3x squared plus 4, definitely good to be u. du is going to be 6x dx. Now I only have x dx, so I kind of know I'm going to have to divide. And so I make the substitution that 1/6 is going to go in the front. Integral. This bottom part is u, so it's going to be u to the negative 1/2 because the square root's in the denominator. Then x dx is going to be the same thing as du. All right, so this 1/6 went right here, this du is right here, and then u is right here to the negative 1/2 power because it was a square root in the denominator. All right, take the integral, that's 2u to the 1/2 plus c. So dividing by 1/2, same thing as multiplying by 2. Or I think about it as 2 and 1/2 cancel each other out. That's how I think about it. All right, and then we just make that substitution, and so I have 3x squared plus 4 to the 1/2 power plus c. And again, you should be able to take the derivative. It will match what's on the inside of your integral, or we also call that the integrand. All right, so we just kind of do that in our head real quick. I multiply the 1/2 down to get 1/6, and then I have 3x squared plus 4 to the negative 1/2. Then I take the derivative of the inside because of chain rule. I got 6x plus 0. So the 6 and the 1/6 will cancel. The x will go right there. Yep, seems like it makes sense. All right, let's practice with some trig now, because of course, we gotta. Trig keeps coming up. So I'm just gonna write snow cone over here for my own use. Use it if you will. All right, so again, I'm gonna let u be the inside of my function. So 3x. That means du is 3 dx. I just have dx here, so I'm gonna divide both sides by 3. Okay, so now I'm good, right? So here's my u, dx is equivalent to 1/3 du. So I really have the integral of cosine of u with respect to u with a 1/3 in front. Hey, the integral of cosine is sine. Right, but it wasn't really u, it was 3x plus c, and now I'm done. All right, so next one's a little tricky. Remember that when you see your exponents like that, I think it makes it a lot clearer if you write it like this. So I see that I have sine of x being cubed. All right, so good candidate to be u. Also, the derivative of sine is cosine, so definitely a good candidate for u. All right, so I'm gonna let u equal sine, take the derivative of both sides. Okay, so I see right here. This is my u. Cosine x dx matches perfectly for du. Take the integral of u cubed du. All right, so that's going to be 1/4 u to the 4th power plus c. And so then I just make that substitution. So sine x to the 4th plus c, and perfect, we're done. All right, let's keep going. All right, if you haven't seen the value of u sub yet, then hopefully you'll see it in these next two examples. So right here, again, very similar example to the last one. I'm going to let u be sine of 5x. Okay, it's just like the last example. So du is going to be 5 cosine of 5x dx. Okay, now I don't have a 5 anywhere here, so I'm going to divide both sides by 5 because I just have cosine of 5x. All right, now I make the substitution. I see that I have u here. Cosine of 5x dx is equivalent to 1/5 du. So I have the integral of u cubed du, the 1/5 I'm going to put out here. Now this integral is way easier looking than this integral. I took the trig completely out of it. So I have 1/5 times 1/4 u to the 4th plus c. That's going to be 1 over 20. And then I have sine of 5x to the fourth plus c. And now I'm done. That's it. Alright, last example here, or one more after this. So very similar to these. I see that I have cosine x squared to the fourth power, so that's a pretty good candidate for you. Right, because it's being put to the fourth power. Now when I take the derivative of cosine is negative sine. The derivative of the inside, because after you chain rule, is 2x. So I have negative 2x sine of x squared dx. Alright, there's a lot going on there. So just remember to do your chain rule, and then you'll be good. Alright, so I see that I have sine of x squared dx, and I have an x here. I do not have this negative 2, so I'm going to divide that to the other side. And so if I rearrange this a little bit, it's pretty clear what we're going to substitute. Right, so I have cosine of x squared to the fourth power. This is my u. It's being multiplied by x sine of x squared dx. Right, so this matches perfectly with what I have over here. This is equivalent to negative 1/2 du. So I make my substitution. I'll put the negative 1/2 in front, u to the fourth power du. So I have negative 1/2 times 1/5 u to the fifth plus c. So I'll simplify that a little bit, make this substitution to the fifth plus c, and now I'm done. Alright, so when you do your u subs, it just makes the whole thing a lot clearer. It cleans up a lot of the messy stuff. Alright, now last one. We're given another differential equation, and I'm expected to solve this. Okay. So I'm going to want to take the derivative. So the first thing I can kind of do is multiply both sides by dx. I just want to move the dx to the other side. Alright, so I get that dy equals 9x squared over square root of 1 plus x cubed plus 5x. All this is 2 times dx. Okay, now I want to take the integral of both sides. Okay, so the integral of dy is just going to be y. And then on this side, I'm going to split this integral into two pieces just because I can. So 9x squared over the square root of 1 plus x cubed dx plus the integral of 5x dx. Remember, if you're adding two functions, you can split it into two totally different integrals, and that's fine. Alright, this one's pretty easy, so I'm not going to worry about this. Over here, I see I'm probably going to want to do a u sub. Alright, so I'm going to, right over here, I'm going to let u equal 1 plus x cubed. That means that du is 3x squared dx. Okay, now I have a 9x squared dx. So I'm going to multiply both sides by 3. Right, so now I have 9x squared dx, which is perfectly what I have here, and that's equivalent to 3 du. So now I'll make my substitution. And so really I have the integral of u to the negative 1/2 power, because it's the square root's in the denominator, times 3 du plus the integral of 5x dx. Okay, so much easier. I'm going to come up here now. I'll draw an arrow. Okay, so the integral of u to the negative 1/2 power is going to be, sorry, that 3 in front, is going to be 2u to the 1/2 power. And then the integral of 5x is going to be 5/2 x squared. And then we're going to stick the plus c at the end. This c is going to absorb all the c's, right? So we had a c over here when we took the integral of dy. We have a c here for this integral. We have a c here for this integral. I'm just going to include all of that into one c here at the end. Okay, now I'm just going to make this substitution. So this is going to be 6. I let u be 1 plus x cubed to the 1/2 plus 5/2 x squared plus c. And now I'm done. All right, that is my original function. They did not give me an initial condition, so I cannot solve for c. So here's my answer, and that's totally fine. All right, that's it. See y'all later.